8051 microcontroller. So these topics are over. After that, we will start internal RAM architecture. So these are the today's topics. Okay, so far we have completed features of 8051, pin diagram, block diagram, and I have given the list of these special pins. So in these special pins, we have VCC, ground, we have reset pin, crystal 1, crystal 2, EA, PSN, and ALE. Okay, last session I told you we will not discuss anything related to external memory interface. So these 3 pins are used for external memory interface. So we'll not go in the detail. Okay, so we see we do not have only these important pins. Okay, so we have some other important pins, so we will concentrate on them. So we will be concentrating more on the pins which we are going to use in the program. So these pins are not used in the program. Okay, so that's why I'm not concentrating much on these pins. So these 3 pins are used for external memory interface that we will not discuss. So VCC, you know, that is we have to give the voltage to microcontroller. So for that VCC pin is used. So VCC pin is available on the 8051 pin diagram, and this pin number is 40. So we have a ground. You know, the ground is the reference point for every electronic circuit. So without ground, electronic circuit is incomplete. So now we will discuss reset pin, crystal 1 and crystal 2. We will not discuss EA, PSN, ALE bar because these 3 pins are used for external memory interface. So we will go with the reset pin and crystal pins. We'll go with the reset pin of 8051. Okay, this is the reset pin, and the reset pin is used to reset microcontroller. The reset pin is used to reset microcontroller. One of the important pin, reset pin is used to reset the microcontroller. Remember, every microcontroller comes with a reset pin. Every microcontroller comes with reset pin. This reset pin is very important in the microcontroller. So without having the reset pin, if the reset pin is not available, or if the reset circuit is not given on the hardware, so some cases your hardware will not work. Okay, so the reset circuit. So first point to remember it, this reset 8051 reset is active high reset. 8051 reset is active high reset. 8051 reset is active high reset. Active high reset means whenever we give 1 on this reset pin, then only microcontroller will reset. And when you give 0, then microcontroller will not reset. I can make a note. It is active high pin. It is active high pin. That's why when we give 1, then microcontroller will reset. This is called as an active high. When we give 1, then only something will happen. This is an reset pin. So when we give 1, then only microcontroller will reset. Okay, so upon reset, what happens is, upon resetting 8051, upon reset, program counter becomes 0. program counter becomes 0. Program counter is a register. Program counter is a register. So after reset, program counter becomes 0. Then all IO pin becomes high. All IO pin becomes high after reset. This is the case of 8051. This is the case of only 8051. All IO pin becomes high. Then stack pointer we call it as SP. Stack pointer becomes 7, 0x7 or 7. Stack pointer becomes 7. Then after that, 8051 enters into ISP mode. ISP stands for in system programming mode. 8051 enters into ISP mode, and it remains into ISP mode for few milliseconds. So first you write down these points. We will discuss one by one. First you note down these points. So program counter is one of the register of microcontroller. This program counter register is available in every microcontroller. Stack pointer register also available in every microcontroller. Okay, after reset, program counter always becomes 0. This is not only the case of 8051. In every microcontroller, program counter register becomes 0 after reset. But the stack pointer will not become 7 in all controllers. Only in the case of 8051 microcontroller, stack pointer becomes 7 after reset. Okay, so why it becomes 7, that you will understand when I explain this internal RAM architecture. So first you understand this internal RAM architecture, you will understand this stack pointer concept also. Okay, later on in the programming, when I start assembly programming, we will discuss in detail what is program counter, what is stack pointer, and all the details. Next is all IO pin becomes high after reset. When you give 1 is nothing but an 5 volt. 1 is nothing but an 5 volt. So in digital electronics, we represent it as a 1. But this 1 is nothing but an 5 volt. As soon as you give 1 or as soon as you give 5 volt on the reset pin, so microcontroller will reset. Microcontroller reset means these things will happen. These things will happen inside microcontroller. That is called as microcontroller is reset. So after reset, PC becomes 0. All IO pin becomes high. So in 8051, total 32 IO pins are given, and all IO pin becomes high. All IO pin becomes 1 or 5 volt. Stack pointer becomes 7, and 8051, that means 8051 microcontroller, enters into in-system programming mode. So in-system programming mode is nothing but an hex file downloading mode. Make a note of this. Or hex file dumping mode. ISP mode means hex file dumping mode. All IO pin becomes high, pins means become input. Yes, they become input. Actually, in 8051, they have not specially mentioned they have not specially mentioned that if IO pin is 1, then only it is input. So if IO pin is 1, you can use it as an output also. Okay, so that is not specially mentioned, but in the books they have given if the pin is 1 means input and 0 means output. There is no such concept in the 8051. If IO pin is 1, that you can use that pin as an input pin. So if you are considering that point, yes, all pin becomes input pin after reset. But there is no such, like there is no such mandatory requirement that for input that pin has to be 1 or for output has to be 0. That is not there. But yes, when it is 1, all IO pin will act as a input pin. High means they are working as an input. Upon reset, all IO pin 1 or all IO pin high means they will work as a input pins. Okay, those who don't know what is input or output, we will discuss in the coming topics. But there is no, those who knows this concept, input or output, remember in 8051, there is no such settings called as input direction and output direction. So this input direction and output direction setting is only given in high advanced microcontrollers. Those settings are not given for 8051. Okay. So come to the ISP mode. After reset, microcontroller will do this, and then microcontroller, your 8051 enters into ISP mode for few milliseconds. Microcontroller enters into ISP mode for few milliseconds. ISP mode is nothing but an hex file dumping mode. Hex file dumping or hex file flashing mode, or we call it as an IC burning also. So this is what is the ISP mode. So what happens is when microcontroller, when 8051 is in the ISP mode, then only we can able to dump the hex file. We can able to dump the hex file. We can able to transfer the hex file. Example, this is microcontroller. Inside this there is a flash memory. Okay, now suppose you have a PC. You have a PC, and in this PC you have written a program. Then you did cross compilation. So after cross compilation, you got hex file. So this is, assume that this is the reset pin. Okay, so you got the hex file after cross compiling this program. Now suppose if you want to transfer this hex file. So when you want to transfer this hex file content inside microcontroller, so what you should do is you have to use one software. Then in that software you have to browse this hex file and you have to click start dumping the hex file. Okay, so you have to start the process. So as soon as you start the process, this software will ask you to reset your 8051 microcontroller. This software will ask you to reset your 8051 microcontroller. So whenever you are starting this process, whenever you are dumping the hex file or whenever you are flashing the hex file, so you have to give 1 on the reset pin. So as soon as you give 1 on the reset pin, then this hex file dumping process will start. Because as soon as you give the reset pin, so these things will happen. Program counter becomes 0, all IO pin becomes high, stack pointer becomes 7, and 8051 microcontroller enters into ISP mode. So as soon as this 8051 enters into ISP mode, so this hex file dumping process will start, and your program will be finally stored inside the flash memory. So whatever the program you have written, that program is converted into the executable code, and that executable code will be stored inside the flash memory. Okay, so and then this after dumping this hex file, then execution will start. Okay, make sure that if you don't reset, means this reset pin remains 0 only. This, if you don't reset, means this reset pin is 0. So if you don't reset 8051 while dumping this or while this process, then your hex file contents will not be stored inside the flash memory. Your hex file will not be dumped into the microcontroller. So you have to give the reset. You have to give 1 on the reset pin to dump hex file contents. Okay, every time this 1 is nothing but an 5 volt and 0 is nothing but an 0 volt. So every time it is not possible you to give 5 volt and 0 volt here. So what hardware designer will do is hardware designer will give the simple mechanism. So they will give the reset circuit. They will give the reset circuit. So using which you can reset your microcontroller very easily. So giving 1 on the IO, giving 1 on the reset pin means you have to give 5 volt here. Giving 0 means you have to give 0 volt here. Okay. So giving 5 volt every time. So if you want to give the 5 volt means from the power supply unit, you have to take the 5 volt and you have to connect that wire on this reset pin. So then reset pin will get 5 volt. And suppose, so once you reset it, once your program is done, you have to remove that reset 5 volt wire and you have to connect the ground wire. Ground is nothing but a 0. So every time will not do this one. Every time will not do this one. So for making this reset process simple, to make this reset process simple, so the hardware designer will give 1 switch on the reset pin. 1 switch will be given on the reset pin, using which you can reset microcontroller very easily. Yeah, we have to provide 5 volt. Yes, every microcontroller board will have the power supply unit, and from the power supply unit, definitely you will get 5 volt all over the board. Yeah, in every microcontroller, we have to press reset button before dumping hex file. But in the latest microcontrollers, now that process, that reset pin is given or reset button is given, but no need to press the reset button while dumping the hex file. So in the latest microcontroller, that mechanism is not used, but in old microcontrollers that is used. Okay, most of the microcontroller they will follow this method. Example, if you are using Arduino board, in case of Arduino board, no need to press the reset button on the Arduino board. When you dump the hex file will be dumped automatically. So no need to press the reset button on Arduino board, but on most of the microcontroller boards, you have to press the reset button. And yes, K2, you are right. So when we dump the hex file contents, old program will get erased. Whatever the old program is stored inside the flash memory, that will get erased. First, old program will get erased, and the new hex file contents will be stored, or new program will be stored inside the flash memory. Okay, now understand this reset circuit. Yeah, after reset, it will not be erased. After reset, when you reset the microcontroller, your old program will not get erased because flash memory is the permanent memory. After reset, old program will not get erased. So while dumping hex file or while flashing the hex file, then only old program will get erased. Okay, now understand this reset circuit. It is very difficult to provide 5 volt and 0 volt on the reset pin manually. And that's the reason we have the reset circuit. That's the reason we have a reset circuit. So this reset circuit of 8051 is recommended by Intel. So Intel said use the reset circuit and give the proper resistor and capacitor values. So this reset circuit is a combination of, it is an RC circuit, we can say. It is an RC circuit. So reset circuit looks like this. There are 2 types of reset circuits are available. Let me draw that reset circuit. 2 types of reset circuits are available. First reset circuit is nothing but a power on reset. First reset circuit is power on reset. So power on reset is an RC circuit. Power on reset is RC circuit. That means resistor and capacitor circuit. This is VCC. This capacitor. It is 10 microfarad capacitor recommended by Intel. Resistor. Let me check this register value once. This is the ground. This is the ground. And this is the reset circuit. Here you have to connect it. The reset pin. This resistor is 0.8K. It is not, it is 8 kilo ohm, 10 microfarad and 8 kilo ohm. Okay, reset pin number is pin number 9 on 8051. And reset is vector. Reset is actually, it is an interrupt only, that is called as a non-maskable interrupt. Reset is non-maskable interrupt which cannot be ignored. No. The old program which was deleted while dumping new program, is that old program is saved in the hard disk. Okay, make sure that there is no concept of hard disk in the case of microcontroller. Inside microcontroller is different. Microcontroller is not a part of computer. Microcontroller is not a part of computer. So microcontroller is different. Okay. So inside microcontroller, you will have only flash memory and RAM. So your program will be stored in the flash memory, and your runtime variables, whatever the variables you declare, and runtime program will be stored inside the RAM only. Okay. There is no hard disk in the case of microcontroller, and program will not be stored in your computer. That is not possible. Yeah. Yes, it is 8.2K. That's right. This is 8.2K kilo ohm resistor. Okay, so this is how the reset circuit looks like. It's a capacitor. It is an RC circuit, resistor and capacitor circuit. This is called as power on reset circuit. This is called as power on reset circuit. This is called as power on reset circuit. So this power on reset is nothing but an see, final target should be, your final target is, you have to give, if you want to reset 8051, you have to give 1 or 5 volt on this reset pin. That's it. So this VCC comes from power supply unit. This VCC comes from power supply unit. Every microcontroller board will have the power supply unit. So you have to connect the adapter output on the power supply unit, and that power supply unit will convert 230 volt into 5 volt DC, and the 5 volt will be given all over the board. Okay, so that is the power supply unit. From power supply unit, you will get the 5 volt. This is the capacitor. So final target should be, you have to give 1 in order to reset 8051. So understand what is meaning of power on reset. Understand what is meaning of power on reset. So power on reset is nothing but as soon as you power on the board, your microcontroller will reset. As soon as you power on the board, microcontroller will reset. So assume that what happens here is, the capacitor will block the DC. Okay, S3 question is whether the program is uploaded if program size is too large and microcontroller flash memory is too small. No, it is actually okay. Question is now microcontroller flash memory is very small. Microcontroller flash memory has limited space. So what if the program size is greater than the flash memory size? What if the program size is greater than the flash memory size, or what if the program is greater which we cannot store it into flash memory? First of all, when you're writing a program, you have to use an IDE, or you have to use the compiler. When you compile the program, if the code size is greater than the flash memory of microcontroller, then your program will not get compiled. If the code size is greater than the flash memory size, then compiler will not compile the program. Okay, so then the next step is dumping hex file. Okay, So first of all, if your code size is greater than the flash memory size, then your program will not get compiled. Okay. And when you're compiling the program, suppose if the compiler is allowing, so you should know what is the flash memory size of microcontroller, and compiler will show the size of your hex file also. So that also you can observe it. So first of all, whatever the compiler we are using, that will not compile the program if the code size is greater than flash memory size. Okay. Now come to this power on reset. Understand what is meaning of power on reset. So power on reset is nothing but as soon as you power on the microcontroller board, your microcontroller will reset. As soon as you power on the microcontroller board, microcontroller will reset. You know the capacitor will block the DC. So this VCC is nothing but 5 volt, and 5 volt is nothing but DC only. On every microcontroller board, you will get the DC voltage only. You will not get the AC voltage. Okay. So the capacitor role is to block the DC. So, but blocking the DC, but when it will block, so this blocking the DC means this capacitor will block the DC. Capacitor will block the DC only if the capacitor is fully charged. Only if the capacitor is fully charged, then only capacitor will block the DC. So what happened? As soon as you power on the microcontroller, VCC, capacitor will get powered up. Capacitor will get powered up, and capacitor will allow this VCC towards reset pin. So VCC is nothing but 5 volt. So this 5 volt is nothing but 1. So as soon as you power on the microcontroller board, capacitor will start charging. And when it is charging, capacitor will allow DC voltage to pass. So DC voltage will pass and it will go to the reset pin. So whenever capacitor is fully charged, capacitor will block the DC. So capacitor will not allow this VCC to flow towards the reset pin. And whenever the DC voltage is blocked here, so this resistor, this is called as pull down resistor, because ground is connected here. If this side VCC is connected, this is called as pull up resistor. So ground is connected, this is called as a pull down resistor. So whenever capacitor block the DC here, then this pull down resistor will pull down the voltage of reset pin. Pull down resistor will pull down the voltage of reset pin. So pull down the voltage of reset pin means this reset pin becomes 0. So as soon as you power on the microcontroller board, capacitor will allow 5 volt to the reset pin. So when the capacitor is fully charged, then capacitor will block the DC. And capacitor will not discharge until unless you will not power off the microcontroller board. Capacitor will not discharge until unless you will not turn off the microcontroller board. So next time when you turn on the microcontroller board, what will happen? So VCC capacitor will pass this 5 volt to the reset pin. As soon as you power on the board, capacitor will pass 5 volt to the reset pin. So, but when this capacitor will block the DC, as everyone knows, it will block the DC, but it will not block immediately after reset. So capacitor will charge. Capacitor charging will start. So when the capacitor is charging, this is the charging time. Assume that this is the fully charging time. Let us assume that this is the charging time. I'll call it as a T. So capacitor will charge, and when it is charging, capacitor will pass 5 volt to the reset pin. So whenever capacitor is fully charged, it will block DC, and when it will block DC, then this pull down resistor will make this voltage reset pin to 0. No, capacitor will not allow AC. Capacitor will block the DC when it is fully charged. There is no AC concept on the microcontroller board. The AC concept will be there only in the socket. Whatever the socket you are having at the home, so that socket will have the AC concept. So we connect the adapter over there. So adapter will convert that AC into DC, and then will be given to the PCB. And on the PCB you will have only DC voltage. So on the PCB you will not have the AC voltage. You will not have the AC voltage. So this capacitor is working with the DC only. Resistor. No, capacitor is fully charged. That actually capacitor charging time will be there. So actually capacitor is the semiconductor device which will charge and discharge. This is how it is designed. So you go in the details of this capacitor charging and discharging. So when it is fully charged, whenever we give the power to this capacitor, so it will start charging, and the charging time of the capacitor depends upon this resistor value and capacitor value used. Resistor value is 8.2, capacitor is 10 microfarad. So the charging time of the capacitor depends upon resistor and this capacitor value. So the charging time will be calculated. So when it is fully charged, and you can actually adjust the charging time of the capacitor. So how much charging time you want? 50 millisecond, 1 millisecond, 10 millisecond. You can adjust the capacitor charging time with the help of this resistor value and capacitor value. So these values are recommended by the Intel. We cannot change it. Okay. Okay, so this is what is called as a power on reset. So what happened now when the capacitor blocked the DC, this resistor will pull down this reset pin to 0. It will pull down reset pin to 0 when the capacitor blocked the DC. So whenever the reset pin becomes 0, then microcontroller will not reset. Whenever reset pin is 1, microcontroller will reset. Okay, so as soon as you power on the microcontroller board, the VCC will be given to the reset pin, microcontroller will reset, and whenever capacitor block the DC, this resistor will pull down this reset pin, or resistor will connect this reset pin to ground. Then this pin becomes 0. Okay, now the question is, this pin, why this pin has to be 0? Why it should not be 1? So what will be the problem if I let this pin to 1? What if I let this pin to 1? Remains on every time reset happens. Why this pin has to be 0? What happen if I let this pin to 1, or if I keep this pin to 1? So if you, K2, you're right. If you keep this pin to 1, your microcontroller will reset again and again. And your microcontroller will not execute program. Microcontroller will not execute software. As long as the reset pin is 1, microcontroller will not execute the software, or it will not execute the program. So if you want your microcontroller to execute software, so then the reset pin has to become 0. As soon as the reset pin becomes 0, then your microcontroller will execute the program, which is stored inside flash memory. You know the CPU is the one which will execute the program. It is inside microcontroller, and inside the flash memory, this program is available. So as long as the reset pin becomes 0, CPU will execute the program. So CPU is inside the microcontroller. That's why we say microcontroller will execute the program. Hope you're getting that point. So that's why this resistor is connected here. If you don't connect the resistor, reset pin remains in the floating state. That will be neither 1 or 0. So there will be no guarantee that program will execute. So this resistor should be connected, and this is called as a pull down resistor. Okay, so this is about power on reset. So for power on reset, what you should do is you have to power off and power on the microcontroller to reset the microcontroller. As soon as you power on the board, microcontroller will reset. And most of the hardware designers, they will follow this power on reset concept. As soon as you power on the board, microcontroller will reset and execution will start. Because this power on reset circuit will reset microcontroller, and after some time, reset pin becomes 0. If the reset pin becomes 0, then CPU will execute the program. Okay, so this is power on reset. So there is another reset circuit available. So some people will actually use this power on reset circuit. Some people will use manual reset circuit. So manual reset circuit is nothing but it's a switch combination. it is a switch combination. So like this manual reset looks like. This is switch and resistor combination is manual reset. Capacitor and resistor combination is power on reset. This is the switch, like this you have to connect. This is the reset pin. You can call it as a switch or you can call it as a push button. Call it as a switch or you call it as a push button. Okay, and this side is VCC. This is called as manual reset circuit. This is called as manual reset circuit. Actually, it is actually RC combination. So after 80 milliseconds, this reset pin becomes 0. So actually, if you want to find out the charging time, when the capacitor is fully charged, then only this reset pin becomes 0. And charging time depends upon it's an product of R and C value, resistor and capacitor value. So resistor value into capacitor value, that will be the after that time your reset pin becomes 0. Approximately it is 82. Approximately it is 82 milliseconds. Approximately 82 milliseconds time. So okay, this circuit is recommended by Intel. We cannot change these resistor values. Okay, so this is resistor over here, and the resistor value again recommended by Intel 8.2K. So this is called as a manual reset. So manual reset means if you want to reset this microcontroller, so what happens if the switch is not pressed? What will happen? Your VCC is nothing but at 5 volt. So VCC is available up to here. So you can see these two wires are open here. This terminal and this terminal is open when the switch is not pressed. This terminal is open when the switch is not pressed. This is kind of wire only. This red line is nothing but a wire only. So what happens whenever you press the switch? Whenever you press the switch, these two wires will get shorted and the VCC will be given to the reset pin. So these two wires gets connected and the VCC will go to the reset pin. So as soon as you press and hold the switch, so this VCC will get connected to reset pin. And when you release the switch, these two contacts will get opened. And the reset pin will get connected to ground. When the switch is not pressed, your reset pin will get connected to ground here. Okay, so when you press the switch, these two contacts will get connected and the VCC will be given to the reset pin. And when you release the switch, your reset pin will get connected to ground. So if you press and hold the switch, as long as you press and hold the switch, your reset microcontroller will be in the reset mode only. And when you release the switch, microcontroller will, this reset pin becomes 0 and microcontroller will execute the program. This is called as a manual reset switch. Yeah, your capacitor, in this circuit, the capacitor is given in such a way that, so when you power off the microcontroller board, then only capacitor will discharge. It will not discharge immediately. Otherwise, it will reset and unreset the microcontroller. So that will not be considered, right? So in this case, whenever you power off the microcontroller board, then only capacitor will discharge. Okay, so these two options are available for reset, manual reset and power on reset. So that depends upon the hardware designer. So hardware designer may give you the power on reset or it may give you the manual reset. Any option, any one of the option will be given to the, any one of the option is given on the PCB. Okay, but on our board, on the Vector 8051 board, we have given both options, power on reset and manual reset. We have given both options, power on reset and manual reset also. Okay, so this is how the 8051, our 8051 reset looks like on our board. On our board, the circuit looks like this. So we have given capacitor and resistor combination. This is power on reset, and we have connected one switch over here like this. Like this, we have connected the switch. So this is the combination of power on reset and manual reset. So as soon as you power on the board, microcontroller will reset. Later on in the middle of suppose later on, if you want to reset microcontroller manually, you press the reset button. Okay, so suppose if you are using only power on reset, then what you have to do is you have to power off and on the board every time. If you want to reset microcontroller, you have to power off and on the board every time. So if manual reset is given, advantage of manual reset is no need to power off and power on the board every time when you want to reset. When you want to reset, just press the button and that's it. It is over. Okay, so on our board, we have given combination of power on reset and manual reset. So this is the circuit given on our 8051 board. Okay, make sure that whatever the 8051 board which we provide it in the lab, that board is not available anywhere on the internet or online sites. And if you are available in the Bangalore, after 1 week we will start hardware. We will start working on hardware. If you are available in the Bangalore, you can come down to the lab and you can practice it on the hardware. See, having hands-on experience on the hardware is totally different. So you can answer, like there are many companies, they will expect hands-on experience on the hardware. And if you practice it in the lab, you will get hands-on experience on the hardware. So that will definitely give benefit in the interview and in the coming days also. No, PWM signals are not given to reset the microcontroller. PWM signals are totally different. PWM signals are not used to reset the microcontroller. It is just pure 5 volt will be given to reset the microcontroller. In the PWM, your voltage will vary. Okay, and make sure that there are some companies now that are looking for hands-on experience. I already said having hands-on experience on the hardware is totally different. And there are some companies that are actually ignoring this COVID batch pass out student. It is because of they haven't done the final year project. Okay, now at least you are having a chance here in the vector. You are having a chance to get hands-on experience on the hardware and do some projects on the hardware itself. Okay, so we will teach in the level, so you can do the project by yourself. We will assign some project to you, and you will be able to do the project by yourself. So you have to do the hardware connection here. You have to write your own software. So when you write your own software, and if you do the hardware connection properly, so you can explain your project very easily in the interview. So I know there are many students, they have not done their B projects. They have purchased from some institutes, and they don't know what is the program. And when the interviewer asks how to explain, also they don't know. Okay, so now you have a time. So if you're in the Bangalore, you can come down to the lab and you can practice it. If you're attending remotely, if you're not able to come to the institute, so then you have to practice it on the software. But software experience will not be accepted by many companies. Only like as an embedded engineer, you should have the hands-on experience. As an embedded engineer, you should have hands-on experience on the hardware. Okay, so if you're in the Bangalore, so those who are staying in the Bangalore, that they have that facility, they can come down to the lab and they can practice it on the hardware itself. Okay, your hardware will start after 1 week. So we will discuss the assembly, and after that we'll start the hardware. Okay, so now we have done with the reset circuit. Remember why reset circuit is required. Now come to the crystal circuit. Okay, reset circuit is important. If you do not have reset circuit on 8051 microcontroller board, you will not be able to dump the hex file. You will not be able to flash the hex file. Okay, and if you do not have the crystal circuit on the microcontroller board, your CPU will not execute any instructions. So only having 5 volt will not activate the CPU. Only having 5 volt will not activate the CPU. CPU needs clock pulses, and that clock pulses are provided by this crystal oscillator. That clock pulses are provided through this crystal oscillator. So for every clock pulse, CPU will do some operation like fetching, decoding, executing. So CPU will do this fetch, decode, execute operation with respect to clock pulses only. And if the clock pulses are not given to the CPU, then CPU will not execute the program. So these clock pulses, the clock pulses are given through this crystal circuit. Clock pulses are given through this crystal circuit. Yeah, clock pulses can be used for bits transmission, but CPU will use these clock pulses to execute the program. But what happens on the hardware, whatever you are saying before, that same thing happens on the hardware only. So for every clock pulse, the bit transmission will occur, but we are talking in the high level. So CPU needs these clock pulses for the internal operation. For every internal operation, CPU needs the clock pulses. Internal operation means CPU, the role of CPU is to execute instruction. But CPU will not execute instruction directly. First, CPU will fetch the instruction, it will decode the instruction, then it will execute the instruction. Okay, so for fetching, decoding, execution, so for every operation, for this every operation, for this every step, CPU need clock pulses. Okay, now understand this crystal circuit. So this is, I will say, this is inside 8051. This is inside 8051 microcontroller. This is outside 8051 microcontroller. Outside of 8051 microcontroller. Okay, so inside 8051 microcontroller, you will have something called as a clock generator. And after that, you will have CPU. You will have clock generator, we call it as a oscillator. Inbuilt oscillator, directly I'll write clock generator. You will have clock generator inside 8051. But this clock generator will not generate the clock pulses by itself. This clock generator will not generate clock pulses by itself. So this clock generator need oscillations from outside. The role of this clock generator is to provide clock pulses to CPU. But clock generator will not generate the clock pulses by itself. This clock generator need and oscillations from external crystal. This is external crystal oscillator. This is the external crystal oscillator. So this external crystal oscillator output is given to the on-chip clock generator. This clock generator is available inside microcontroller. We call it as oscillator. So this external crystal we have connected. So we should call it as external crystal only. External crystal is connected, and the value of external crystal which is connected to 8051 is 11.0592 megahertz. 11.0592 megahertz is the crystal oscillator value. Okay, now you need to understand this crystal, this operation. Okay, so this external crystal output is given to the clock generator. Clock generator output is given to the CPU. So understand what happens here. So as soon as you power on the board, your crystal circuit will get the VCC. And if the crystal circuit get the VCC, this crystal will vibrate. This crystal will vibrate. And when it vibrates, it generates oscillations like this. It generates oscillations like this. When it vibrates, it generates oscillations like this. And these oscillations are given to clock generator. So what clock generator will do is, clock generator will convert each oscillation into clock pulses. Clock generator will convert each oscillation into clock pulses. And these clock pulses are given to CPU. Each oscillation will be converted into the clock pulses, and these clock pulses are given to CPU. So CPU will use these clock pulses to fetch, decode, execute instructions. So whenever you start the power, if you power on the microcontroller board, crystal will get VCC, and when the crystal get VCC, it will vibrate, and due to vibration, it will generate oscillations like this. It will generate oscillation, that output will be given to clock generator. So clock generator will convert each oscillation into one clock pulse. Each oscillation into clock pulse. But now, now here we will discuss how many oscillations are generated in 1 second and how many clock pulses are generated in 1 second. Okay, if the crystal oscillator value is 11.0592, if the crystal oscillator value is 11.0592, then this crystal oscillator can generate 11.0592 into 10 raised to 6 oscillations in 1 second. This crystal oscillator can generate 11.0592 into 10 raised to 6 oscillations in 1 second. That means this crystal oscillator will generate 11.0592 oscillations per second. So 10 raised to 6. So megahertz is nothing but 10 raised to 6. So these many oscillations are generated by this crystal oscillator in 1 second, 11.059200. And clock generator will convert each oscillation into clock pulses. So this clock generator will also generate 11.059200 clock pulses per second. 11.059200 clock pulses per second. So clock generator will convert each oscillation into clock pulses. So these many clock pulses will be given to the CPU. So in case of 8051, this is the 8051 CPU. So 8051 CPU is getting 11.059200 clock pulses in 1 second. 11.059200. So that is 00 here. These many clock pulses will be given to the CPU. Okay, now understand this point. Okay, first you make a note of this one. No, crystal is not present. I clearly mentioned this is outside the microcontroller. This is clock generator is available inside the microcontroller. Make a note of this. No, this crystal is already, question is, do we need to connect external crystal while programming in the lab? No, this crystal is already connected on the microcontroller board. This comes on the microcontroller board. When you buy our, whether it is vector board or when you buy board from outside or you buy board online. So on the board itself, you will get this crystal oscillator, external crystal. Okay, so no need to connect external crystal while programming. So this will be there on the board. And when in the companies also, when you get any board for practice or when you get any board for project, so on the board itself, the crystal will be there. That is the hardware designer headache. That hardware designer has to take care. You have to take care about programming. No, this board, this crystal, before crystal will be there on the board itself. So no need to buy this crystal from your side. This is available on the board itself. Okay, so next point is, now the CPU, 8051 CPU is getting these many clock pulses in 1 second because of this crystal value. Okay, so let me show you this crystal oscillator on the board. Okay, so this is our 8051 microcontroller board. This is the 8051 microcontroller board. So this is 8051 microcontroller. This is nothing but an 8051 microcontroller. Okay, and this is the crystal oscillator. This is the external crystal oscillator, this one, and this is the microcontroller. So on the board itself, you will get this crystal oscillator, this external crystal. If you check here, 8051 development board. If you search for 8051 development board, this is some online sites are giving this board. So this board, whatever the board it is, this is another board. Okay, so here observe this side also. This is the microcontroller and this is the external crystal. This is available on the board itself. If you buy this board online, also on the board itself, you are having this crystal. Okay. Next is, if you go to another microcontroller board, you see this is the crystal. X2 given, right? This is the crystal, this is microcontroller. This is microcontroller and this is the crystal connected on the board. So you no need to worry about this crystal. It will be there on the board itself. It will be there on the board itself. Power on the circuit. Here it is. This is the power supply unit. This is the power supply unit, and this is the regulator IC 7805. This is the regulator IC 7805, which will provide 5 volt on the board to each and every IC. It will provide 5 volt LCD, LEDs. This IC is there, this IC there. From here, the power will be given to each and every IC of the microcontroller board. Okay, so from here only it will provide it. Okay, so this is about the crystal. So one more point you need to understand. So this CPU, whatever the 8051 CPU we are using it, this I will write clearly, 8051 CPU. Whatever the 8051 CPU we are using it, this 8051 CPU, to execute one instruction, this 8051 CPU need minimum 12 clock pulses. Minimum 12 clock pulses are taken by 8051 CPU to execute one instruction. Minimum 12 clock pulses are taken by 8051 CPU to execute one instruction. And the CPU is getting these many clock pulses in 1 second, 11059200. So these many clock pulses CPU is getting in 1 second, and to execute one instruction, CPU needs 12 clock pulses. So suppose if I want to know how many number of instructions per second, how many instructions this CPU can execute in 1 second. If you want to know how many instructions, or if you want to calculate how many instructions this CPU can execute in 1 second, so these many clock pulses are coming in 1 second, and to execute one instruction, 12 clock pulses are taken by 8051 CPU. So these many clock pulses divided by 12. So these many instructions 8051 can execute in 1 second. So let me open the calculator. So it is 11059200 divided by 12. So it is 921,600. 921,600. So 9,21,600 instructions per second. So if the CPU 8051 CPU is getting 11.0592 megahertz clock pulses in 1 second, that means this 8051 CPU can execute 9,21,600 instructions in 1 second. Your 8051 microcontroller, actually the CPU is the one which is executing instruction, but we say like that, your 8051 microcontroller can execute 9,21,600 instructions in 1 second. but still this 8051 is called as slower controller. Still it is called as slower in execution. These many instructions your 8051 can execute in 1 second. No, for simple instruction 12 clock pulses, for complex instruction it will take more than 12 clock pulses. I consider 12 clock pulses for simple only. So if the crystal oscillator value is 11.0592, clock generator will generate these many clock pulses, and this 8051 CPU will execute these many instructions in 1 second. Okay, so 9,21,600 is not a small count. It is also a big count, but then also this 8051 microcontroller is called as slower microcontroller, slower in execution. See, what if 9,21,600 instruction per second is less instructions? So that means you just imagine faster controllers, how many instructions that faster controllers can execute. So that will go to crores, billions, that will go to billions. Okay, so this is the calculation. Okay, small calculation here is this crystal oscillator 11.0592 megahertz. This crystal oscillator, this is the crystal oscillator value. So this 11.0592 megahertz means this external crystal or this crystal can generate 11.0592 megahertz oscillations in 1 second. 11.0592 megahertz oscillations in 1 second. That is the meaning of 11.0592 megahertz value. And you know very well, number of oscillations per second. Number of oscillations per second called as frequency. Number of oscillation per second called as frequency. Fastest controller, it is I think 2.2 gigahertz controllers are available. 2.2 gigahertz controllers are available. They are actually there in the ARM controller only. So that is the fastest controller available in the market. ARM controllers are fastest controllers. This 11.0592 megahertz, this represents these many oscillations in 1 second. Write down one note. Number of oscillations per second. The number of oscillations per second is called as frequency. The number of oscillations per second is called as frequency. The number of oscillations per second is called as frequency. So this number 11.0592, this number represents how many oscillations has to be generated in 1 second. This number represents how many oscillations has to be generated in 1 second. So number of oscillations per second is called as frequency. Okay, so these many oscillations are getting generated in 1 second. What suppose instead of connecting 11.0592 megahertz, suppose if I connect here if I connect 12 megahertz crystal oscillator, if I connect crystal oscillator of 12 megahertz, then what will happen? So this external crystal will generate 12 megahertz oscillations in 1 second. Clock generator will generate 12 megahertz clock pulses in 1 second. And if the 12 megahertz clock pulses are getting in 1 second, so 12 megahertz is nothing but 12 into 10 power 6. 12 into 10 power 6. So if these many clock pulses are coming in 1 second, so if you go for divided by 12, so then this count becomes 10 lakhs. 10 lakh instructions per second. 10 lakh instructions are nothing but 1 million. 10 lakh instructions are nothing but 1 million. Okay, now understand what happens here. What happened here? If I use 11.0592 megahertz frequency, if I use 11.092 megahertz frequency, then the CPU can execute 9,21,600 instructions in 1 second. Suppose instead of 11.052 megahertz, if I connect 12 megahertz frequency, if I give 12 megahertz frequency to 8051, then 8051 can execute 10 lakh instructions. So this count is greater than 9,21,000 obviously. This count is greater than 9,21,000. So what happened here is, if I increase the frequency, I increased frequency from 11.059 to 12. So the CPU, if I increase the frequency, then CPU also has increased count of executing instruction per second. CPU also has increased count of execution of instruction per second. So if the frequency increased, then the number of instruction execution number will increase. So executing more instruction means faster speed. Executing more instruction means faster speed. Executing less instruction means slower speed. Okay, so what happened if I increase the frequency, then the speed of execution of CPU also will increase. And if I decrease the frequency, if I go for 11.0592, this 8051 CPU will execute 9,21,000 instruction. So what will happen? That will decrease speed of execution of instruction. If I decrease the frequency, that will decrease speed of execution of instruction. Okay, now we can say it clearly. We can write this statement clearly. Frequency will decide the speed of execution of instruction. If I increase the frequency, speed of execution of instruction will increase. If I decrease the frequency, speed of execution will decrease. Okay, so we can say the frequency is directly proportional to speed. Frequency is directly proportional to speed. If I increase the frequency, number of instruction executed per second will increase. If I decrease the frequency, number of instructions will decrease. Okay, S3 question is, why is a crystal frequency of 11.0592 megahertz often used in 805 family? I think I have said it earlier also. The reason behind using this odd frequency is to set exact baud rate of UART communication. Suppose if you are using UART for serial communication, and there is something called as a baud rate setting in the UART. So to set exact baud rate in the UART communication, so this odd frequency will help you. This odd frequency will help you out to set the exact baud rate in the UART. And suppose if you set exact baud rate in the UART, then only you can do serial communication properly. If you change this frequency to 12 megahertz, what will happen is you will not be able to set exact baud rate in the UART. You will not be able to set exact baud rate in the UART. Okay, so that's the reason this 11.0592 megahertz is oftenly used for 8051. Yeah, actually you can change this crystal oscillator value and you can increase the speed, but you have to understand what is the frequency, maximum support of the frequency. That also you have to consider, right? It is not like, okay, now you got the point that if I increase the frequency, the speed of execution will increase. You got that point, but I cannot increase this frequency to, like 20 megahertz, 30 megahertz, 100 megahertz. I cannot make it, because whatever the internal circuit of 8051 is, this internal circuit of 8051 will work only if the frequency is up to 12 megahertz. If you give a frequency greater than 12 megahertz, then what will happen? The internal circuit of 8051 will not work. If you increase the frequency, what happened? This clock pulse speed will change. This clock pulse speed will change, and internal logic gates will not actually activate and deactivate for this speed. And that's why the internal circuit of 8051 will not work if you increase the frequency or if you are going about 12 megahertz. In the features of 8051, I clearly mentioned the frequency support is up to 12 megahertz. Frequency support is up to 12 megahertz. And if you are going beyond 12 megahertz, then the 8051 internal circuit will not work. So that's why we have to go up to 12 megahertz only. Okay, so up to 12 megahertz you can give. So you can give 11.0592, you can give 8 megahertz, you can give 4 megahertz, but not more than 12 megahertz. Okay, so this is the limitation in the microcontroller. And remember, every microcontroller will have this type of limitation. Every microcontroller will have this type of limitation. So there is no microcontroller in the world which will work on any frequency. There is no microcontroller in the world which will work on any frequency. This has a limitation, and you have to read that limitation, and based on that you have to provide it. Okay, so all these things, like what should be the frequency given to microcontroller, this, or what type of crystal we have to use it on the hardware, this everything will be taken care by hardware engineer. This everything will be taken care by hardware engineer. But you should know what is the crystal used on the hardware. That is your responsibility as an embedded engineer, as a software engineer. You should know what is the crystal used on the hardware. That is very, very important. That is mandatory. If you don't know this one, there are actually some calculations inside microcontroller. Some calculations depends upon this crystal only, depends upon the crystal value. So you should know how much crystal is connected. Okay. Yeah, maximum frequency limit. Yes, you got the point, A16. The maximum limit of the frequency depends upon the hardware. That is correct. Okay, so this is about the crystal theory. And this crystal circuit, this external crystal circuit is designed using a crystal oscillator. So there are two crystal oscillators are used, crystal 1 and crystal 2. There are two crystal oscillators are used, and using which this operation will happen. Okay, in the 8051 material, we have given this crystal circuit. Please go through that crystal circuit and check how it is, how the crystal circuit is. So I'll not give the diagram now. This is about the crystal circuit. So two capacitors and one crystal oscillator and two capacitors are used. One crystal oscillator, two capacitors are used. If you search for 8051 crystal circuit, so you will get this crystal circuit. This is how it looks like. This is the crystal oscillator, and these are the two capacitors. Okay, and this is connected to crystal 1 and crystal 2 pins. The output of this crystal is connected to crystal 1 and crystal 2 pins. So from here you are getting oscillations inside the controller, so clock generator, and after that it will go to CPU. This is the clock generator. This is the crystal connected like this. Okay. So go through it for more detail. Okay, next concept is, okay, now we have discussed some basic part. We discussed some basic things. So this is the power supply unit, which will provide 5 volt on all to all ICs of microcontroller board. So this is the board, and definitely you will get power supply unit on the board. The role of this power supply unit, the role of the power supply unit will be converting 230 volt AC, converting 230 volt AC to 5 volt DC. Microcontroller will not work on 230 volt AC, so that converting 230 volt AC to 5 volt DC will be taken care by this power supply unit. Okay, so the half of the unit is given here, half of the power supply unit is given here, and we are using adapter also. We are using adapter also. That adapter also will do half of the work. If you check for 9 volt 1 ampere power adapter, so this adapter also will do half of the work. Okay, this 9 volt and 1 ampere we will use usually. So 9 volt 2 ampere also you can use it. So this adapter will do it, right? Inside this adapter you will get the transistor. So you know the transistor will step down the voltage. See 230 volt, if you give 230 volt AC, so 230 volt AC should be converted to 9 volt AC, so with the help of transformer. So when you open this adapter, inside this adapter you will get transformer and bridge rectifier. Transformer and bridge rectifier is available inside this adapter. And from here you will get 9 volt DC. From here you will get 9 volt DC. So 230 volt AC will be given to this one. 230 volt AC will be given to this adapter, So this adapter will convert 230 volt AC into 9 volt DC, and this will be given on the microcontroller board. So that output you have to connect here. That adapter output you have to give here. So 9 volt will be given here, and this IC will convert this 9 volt into 5 volt. This IC will take the 9 volt, it will convert into 5 volt, and the 5 volt will be given to microcontroller and all other ICs and components of this microcontroller board. So this 5 volt comes from this power supply unit. Wherever you see the ICs, wherever you see the component, there this 5 volt will be given here, here, and here, like this. So here also, this here also. So everywhere the 5 volt will be provided. Okay, that is the role. Yeah, for LCD also same supply, for LEDs also same supply, for there are some switches are there, for this also same supply only. That is voltage. This IC is nothing but an 7805 IC. This IC is nothing but an 7805 IC. This IC is nothing but an 7805 IC. 7805 IC, which will convert that 9 volt into 5 volt. 7805. That is called as voltage regulator IC. This is available in different packages. This is the IC used on our board, 7805. It is called as voltage regulator IC. Bridge rectifier actually. Bridge rectifier, you search for bridge rectifier IC. This bridge rectifier like this, it will come, bridge rectifier. W10 they have given, W10 bridge rectifier like this, it will come. So actually this bridge rectifier will be used on used inside this adapter. What are the adapter I have shown you, right? Inside this adapter, this bridge rectifier will be there. Transformer as well as bridge rectifier. Suppose if you're having 5 volt 1 ampere adapter, you can directly give it to the microcontroller board. So no need to use that 7805 also. Okay, so this is about the crystal circuit. So okay, now we have discussed about this one. So we did this is the microcontroller. We discussed what are the features of microcontroller. Later I will, when I start hardware, I will explain each and every IC, what are the IC numbers, why these are used, everything I will explain. What are these, everything I will explain one by one. So we have discussed about, this is the reset circuit of 8051, and as I told you, we have used power on reset and manual reset together. So this is the capacitor. This is the capacitor. Somewhere resistor will be connected. This is the capacitor for power on reset, and this is a reset button for manual reset. This is for manual reset. Okay, so the capacitor and reset combination is the power on reset and manual reset. So we discussed this one, and this is the crystal oscillator which is available on the board. This is the crystal oscillator available on the board. Okay, so we have discussed so far this features of 8051 microcontroller. We discussed the reset circuit and crystal circuit and some basics of power supply unit. Okay, so then now we will go inside the microcontroller. Inside this 8051 microcontroller, we have a RAM. So this RAM is divided into some several parts. This RAM is divided into some several parts. Okay, so that actually to understand in which part or how many parts are there inside the RAM. So for that you have to understand architecture of this microcontroller. You have to understand architecture of this internal RAM. Okay, so now we are going to work on the architecture of the internal RAM. We are going to discuss architecture of the internal RAM. Which pins you are talking about? S28. What are the pins left for connection? Which pins you are talking about? Are these pins you are talking about? Crystal pin? No. Crystal is connected. This crystal will be connected to 18 and 19 number pin. So whatever the 18 and 19 number pin is there, right, that will be connected here. Okay, so these are not crystal pins, these are IO pins. Whatever pins you are see here, these are IO pins, these are not crystal pins. These are not crystal, these are IO pins. So crystal, this external crystal pins are directly connected to 18 and 19 number of microcontroller. It is connected on the board itself. Okay. So for this you have to understand internal RAM architecture. There are two reset. It is because of this board can be used for this designed by Vector, and this board can be used for 8051 and AVR microcontroller also. This board can be used for 8051 and AVR. For 8051, one reset. For AVR microcontroller, one reset. Same reset cannot be used for 8051 and AVR. Okay. So now we are going in the details of internal RAM architecture. We are going in the detail of internal RAM architecture. So give the heading as internal RAM architecture. Okay, as we discussed earlier, your 8051 internal RAM is divided into two parts. 8051 internal RAM is divided into two parts. 8051 internal RAM is divided into two parts. So this lower 128 bytes of RAM is called as user RAM, and this upper 128 bytes of RAM is called as SFR area. So here all SFRs are available. So the starting address of user RAM, this is called as a user RAM, this is called as SFR area. Starting address of the user RAM is 0. I will write hexadecimal number. Starting address of the user RAM is 0, and it is 128. So 0 to 127. So hexadecimal of 127 is 7F. Okay, so in bracket I will write decimal number, decimal 128. So 0 to 7F. 0 to 7F is the range of, or these 0 to 7F addresses comes under the user RAM. So 7F plus 1 is nothing but an hexadecimal 80. Okay, sorry, that is 7F is nothing but an 127, decimal 127, and 128 is nothing but a decimal 0x80. 0x80 is the hexadecimal, and decimal of 0x80 is 128. So 0 to 127 is the user RAM, and 128 to 255, 128 to 255 is your SFR area. So I have given the range of decimal also. So in decimal and hexadecimal, 0 is 0. So 0 to 7F is the range, address range of user RAM. This is considered as user RAM, 0 to 7F. And 80 to FF, hexadecimal 80 to hexadecimal FF is used as a SFR area. All special function registers are available in the SFR area. So special function registers are nothing but an accumulator, stack pointer, a PSW. Okay, so these registers are available in the SFR area. So user RAM is used to store your runtime data. So you have to store runtime data in the user RAM only. Don't store runtime data in the SFR area. Okay, total size of the RAM is 256 bytes. Total size of the RAM is 256 bytes. Okay, but the complete 256 bytes cannot be used as a user RAM. You cannot store your user or runtime data into total 256 bytes of RAM. You can store your runtime data into first 128 bytes only in the user RAM only. This is reserved for special function register. So this 128 plus 128, that is called as a 256 bytes. So here only registers are available. This space is reserved for special function registers, and we cannot store runtime data into this area. So only this much space is available to store our data. Only this much space is available to store our data. I said complete RAM size is 256 bytes, but out of 256 bytes, 128 bytes is given for user. Out of 256 bytes, 128 byte is given for user. So user can store the runtime data. Okay. So this is the internal RAM. Your internal RAM divided into two parts: SFR area and user RAM. Okay. Again, the user RAM divided into three parts. User RAM is divided into three parts. Why they have given SFR area? Okay. Remember, SFR is special function registers, and SFRs are used for hardware communication. Make a note of this. SFRs, special function registers, are used for hardware communication. If you want to communicate with the hardware, if you want to communicate with the IO pin, if you want to communicate with the UART, if you want to communicate with the interrupt, so for all that operation, for hardware related operation, we use SFRs. You cannot use C language. In the C language, there is no predefined function to communicate with the hardware. So the SFR, all SFRs are available in this area. All the special function registers are available over here. That's why this area is called as a SFR area. Size of the RAM is 128 bytes. Size of the RAM you consider as 128 bytes. If the interviewer asks you what is the size of the RAM, you tell 128 bytes only. Okay, in the case of 8051, size of the RAM is 128 bytes. Okay, so total size is 256 byte, but we can use only 128 bytes. So how much you can use, that only you have to answer. Okay, so then next is again user RAM divided into three parts. Okay, so again in that three parts, one of the part has four parts again. Okay, so that gets complicated. So in the next session, we will discuss more in the details. Like we will discuss what is inside the user RAM, how many SFRs are available, all the details we will discuss in the next session. Okay, so before coming to next session, please revise today's topics. Okay, so today we will wind up here. In the next session, we will continue. Thank you guys for attending virtual classes. See you with